So okay, now in this lecture we will study the second method to solve the simultaneous equation, that is the reduction method. So we will consider system of equations a11x plus a12y plus a13z is equal to b1, a21x, a22y, a23z is equal to b2, a31x, a32y, a33z is equal to b3, and this third equation we write in the matrix form. So in matrix form, that is Ax is equal to B, we say this as the first equation. So A matrix A11, A12, A13, A21, A22, A23, A31, A32, A33 into variable matrix x, y, z is equal to B1, B2, B3. Now here in the reduction method, reduce A to upper triangular matrix. So upper triangular matrix means what actually this? So if we upper triangle will be if A is the matrix is reduced to this form A11, A13, after A12, A13, 0, A22, A23, 0, 0, A33. So this triangle is formed here. That is below principal diagonal when the elements are 0. This is called upper triangular matrix. Other type is the lower triangular matrix. So A is equal to, suppose if we reduce the matrix to A11, 0, 0, A21, A22, 0, A31, A32, A33. So here the triangle is formed, and this is called lower triangular matrix. So we reduce A to upper triangular matrix by elementary row transformations. Column transformation is not possible. To upper triangular matrix by row transformations. While doing the operations, you do the operation on both sides. What operation we are doing on A? You do the same operation on this B matrix. Do same operation on matrix B. So now we'll understood with the example how we solve system of equations by reduction method. So solve by reduction method. So suppose x plus y, 4 minus 4z, 2x plus 3y plus 6z minus 5 equal to 0, 3x minus 2y minus z is equal to 4. So solution. Given system of equations, write in the standard form. So x plus y plus 4z is equal to 4. 2x plus 3y plus 6z is equal to 5. 3x minus 2y minus z is equal to 4. Now we write this system in matrix form. That is Ax is equal to B. So A means the coefficient matrix. So 1, 1, 4, 2, 3, 6, 3 minus 2 minus 1. X, Y, Z, 4, 5, 4. Now by elementary row transformations, we reduce this A matrix to upper triangular matrix. So here 1 is already here, so we will reduce this to element 0. So by R2 is replaced as R2 minus 2R1. R3 will replace R3 minus 3R1. So 1, 0, 0, 1, 0, like this we proceed. So by this operation, so matrix is reduced to, so 1, 1, 4, first row remains as it, second check, 2 minus 2, 0, this here 2 element, minus 2 into 1, so 2 minus 2, 0, 3 minus 2, so 1, 6 minus 4 into 2, 8, so minus 2, 3, now this operation, so 3 minus 3 into 1, so 0, minus 2 minus 3, so minus 5, minus 1 and minus 12, so minus 13, x, y, z is equal to, now same operations you do on RHS matrix B. So first element 4, so 5 minus 4 into 8 means minus 3, 4 minus 3 into 4, so 12, 4 minus 12 is minus 8. Now next requirement 1 here is already available, so you want to reduce this minus 5 to the 0, so we'll do this operation by R3 is replaced as R3 plus 5R2, so 1 into 5. Actually when we are doing this must not be depleted, or that is already which zeros we have obtained, that must not be depleted. So by this operation matrix reduces to 1, 1, 4, 0, 1, minus 2. Now third is a 0 plus 5 to 0 is a 0, minus 5 plus 5 into 1, so plus 5 is a 0, minus 13 and minus 10, so minus 23. X, Y, Z is equal to, same operation here, 4 minus 3, here minus 8 and minus 15, so minus 23. So this is the reduced matrix to the upper triangular form. Now you take the products, so we get here x plus y plus 4z, y minus 2z minus 23z is equal to 4 minus 3 minus 23. So by equality, x plus y plus 4z is equal to 4, y minus 2z minus 3 and minus 23z minus 23. So z is equal to 1. Now put this value in our equation. So y minus 2 into 1 is equal to minus 3. So y is equal to minus 3 plus 2. So y is equal to minus 1. Now put these two values in first equation. So x minus 1 plus 4 into 1 is equal to 4. So x is equal to 1. So therefore solution is x is equal to 1, y is equal to -1 and z is equal to 1. So this is the answer. So this is about the reduction method which is used to solve simultaneous equations. Thank you very much.